Hello, everybody. Welcome to OpenCV Live. Today, we have a very special episode about our challenge called OpenCV Bin Picking Challenge. It is sponsored by Intrinsic and Orbeck, and it is in collaboration with the University of Hawaii and the BOP Challenge Group. And today, joining us is Vahe Taamazyan, who is a senior imaging scientist at Intrinsic. He's going to explain the competition. We have already done one episode about this competition, but now we have more to share because we have distributed more, the data, the code, etc. So we'll go over that. And before before Vahe explains everything and we discuss the competition, we have Phil Nelson with us, who is the producer of this show. He is the director of content and creative at OpenCV. And if anything goes wrong, it is his fault. Hi, Phil.
Yes, good morning, Satya. It's me, Phillip. I am your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. My friends out there know it's Mr. Nelson if you're nasty, but you can call me Phil. On this show, there's a couple of things we do on every single episode, the first of which is a special giveaway to you in the audience. Stay tuned. Later on in the episode, I will be asking a trivia question based on today's presentation, and the first person to answer that question correctly in the Zoom chat will win the OpenCV course of their choosing. You can see what courses are on offer by going to opencv.org/university. We're also taking questions from you in the audience, and we will do our best to answer them, as the great late Satoru Iwata would have said, directly. So please use the Zoom Q&A button at the bottom of the screen if you're on Zoom, or just ask your question wherever you're watching on the wide world of Al Gore's internet. We're live on YouTube, LinkedIn, Twitch, and probably some other places I'm not aware of if people are doing their jobs and pirating this show like they should. Having said that, before we get started, there's a couple of things we want to remind you about. OpenCV is a nonprofit organization that provides an open source library absolutely for free. Doc, would you like to talk a little bit about the ways people can support OpenCV and why it's important to do so?
Yeah, so OpenCV is supported both by individuals as well as by organizations. So if you are part of a large organization, please reach out to your manager and nominate OpenCV as one of the libraries you would like to support. In some of the companies, large companies like Qualcomm, Apple, etc., they also have a program which allows they match the contribution.
Right.
Whatever you contribute, sometimes even when you contribute your time to OpenCV, they match in terms of dollars, right? So please reach out to your managers and either donate directly or at least encourage your managers to donate to OpenCV or make the case for it.
Or become a member organization. One of the
That's right.
main ways that OpenCV is supported these days is through the generosity and good sense of many large organizations. We just added a couple of new ones like Qualcomm and ARM. Super excited to have them on board, and there'll probably be a few more coming in soon that we'd love to tell you about. You can also sponsor us on GitHub. You can go to github.com/sponsors/OpenCV. A big shout out to the 14 of you out there that do that.
It has increased.
Yeah, we dropped down, I think, into the 9 territory, and now we've got 14. I'll read their names out here. Private sponsor, my favorite kind of sponsor. We've got Patsikin. We've got Brandel, Stefan there on vacation apparently. Michael, looks like. RoboFlow, the homies. Jesus Anaya. We've got DJ Greenwood. These are our stalwarts here. Tala Hussein. We've got Runjia Lee. We've got a bunch of new folks. Nick Libertini, been here for a while. Blue Jay, been there for a while. Rotus Laboratories, been there for a while. Victor V, also longtime sponsor, and a new Sean Walbridge, new sponsor. We love to see it, folks. Thanks so much. It really it warms my heart to open up this page each week and see new people on there. It really means a lot to us. You can also buy a T-shirt. OpenCV has merchandise over at opensv.myspreadshop.com, including the relatively new import CV2 shirt. It's all you need, folks. And who knows? Maybe with OpenCV 5 coming out, that command will change. Spoiler alert, who knows? Send us an email about what you think about that. We've also got the OpenCV logo in a bunch of different styles and buttons, pins, bags, pet bandanas. We've also got the I Love OpenCV shirt in 3 different flavors: English, Simplified Chinese, and en Espanol. So go ahead and check those out at opencv.myspreadshop.com.
I
But
need to
we're
order
here
some of
today
these.
to talk about.
I'm going to go for. I'm going to several talks in the next few months, so I should order
Okay,
some of these. One for every
you
day
should
of the
do a
talk.
giveaway at your talks. The best question gets a shirt.
That's
Do you want to tell people what your talks are here at the top of the show before we get started?
Oh, there's okay, February 28th, we have CV for Smalls. This is a talk that I'm giving in Tucson, Arizona. And this is basically it's about how computer vision is used for elderly, toddler, and infant care and what are the challenges there. Then we have an OpenCV 5 talk March 25th in Santa Clara. May 21st or May 12th, we have a tutorial on image segmentation at the Display Week conference. We also have a full day event on May 12th by OpenCV. This is like the OpenCV conference that is coming up on May 12th. If you are in the Bay Area region, please, visit us, join us for that conference. And then I have on May 21st or so, I'm slipping on these dates. We have the Embedded Vision Conference where I have a talk on OpenCV 5. I also have a tutorial on using large language models and computer vision. And then we have CVPR, obviously, where we have the workshop and we have our booth. So lots of activities in the next few months.
Yeah, and speaking of CVPR workshop, the reason for the season, the reason we're here this week is to talk about something attached to that CVPR workshop, the bin picking challenge, the perception challenge for bin picking. One more quick note before we get started here. A shout out to Carlos in the chat here saying they just watched Strange Days, which I've been telling you all to watch for months now. The 1995 Catherine Bigelow, Ralph Fiennes, Angela Bassett, phenomenal movie. Weirdly prescient about current times. Go check it out. I think it's up there with Hackers in terms of that era's future forward science fiction. So thanks, Carlos, for taking my excellent advice. Having said that, let's get started. We've got a lot to talk about today. We're going to start by talking about what is bin picking, why did we create this challenge, what are the prizes, who are the sponsors, and all of that good stuff. By welcoming our guest, Vahe. Say hi to the good people out there.
And a little background also would be great.
Hi everyone, I'm Vahe Taamazyan. I'm the senior imaging scientist at Intrinsic and also helping organizing the challenge with OpenCV guys.
Well, helping Vahe is the main person who is driving this, so to speak, the technical side. He's driving all of it.
Mm-hmm. Helping is understating, I would say, absolutely. So I think the best thing to do, would you mind just sharing your screen and let's talk about the challenge a bit and yourself.
Sounds great. Let me start with the challenge website, which I think many of the people who joined the webinar already seen. But just to remind, the link to the website is bpc.opencv.org. That's the main platform where we have the challenge running. So I guess it makes sense to just give a little bit of background on the challenge, right? On what is this all about? Why do we even decided to sponsor this as Intrinsic? And maybe you also guys could share why OpenCV wanted to run this. What, as you guys mentioned, what is bin picking and what is the main goal of the participants here? So one of the key aspects of robotics is being able to interact with the objects in 3D world, right? As humans do, you want to be able to know where is, let's say, the chair or your phone. You want to be able to pick it, right, and manipulate these objects somehow. This is something that people do quite easily. Like even for a child, it's very easy to pick up objects, put them to some other places. For robots, this is a very complicated, like a challenging problem. And there is even so-called Moravec's paradox, which says that surprisingly, it's easier for us to solve these high-level intellectual problems. Like, for example, playing chess was much easier to solve than simple things like walking or manipulating different objects. And this is like very counterintuitive, because for humans or even for animals, this is the opposite, right? It's much easier to learn how to walk or how to grab objects than to learn how to play chess well.
Yeah, machines do not have instincts. It doesn't quite work that way.
Exactly. So this is an interesting paradox of robotics, and to some extent, with this beam picking challenge, we're trying to solve this paradox and trying to help the robots manipulate the objects better. So the process of beam picking is what it sounds actually. It's about being able to grasp the objects from various bins, various baskets, containers, and in order to be able to do that, and to do that with very high precision, as it's usually required for industrial robotics, you need to be able to know the poses of the objects with the very high accuracy, which means you need to know how the pose is oriented in 3D world and where it's located very precisely, like ideally with sub-millimeter precision, but that also depends on the application. So once you know the pose of the object, which is usually defined as like a 6D vector, 3 coordinates and 3 rotation angles. Once you know the pose, you can give that information to the robot, and the robot can do some motion planning and can try to grasp the object, move it somewhere, do something with the object, or try to avoid the collision with the object, which is also sometimes very important. So this problem of being able to detect the parts and detect their pose in the world is a very important computer vision problem. In fact, this problem is there for many years by now, and there is even the benchmark for this, which is called BOP, Benchmark for 6D Open Object Pose Estimation. This benchmark is out there for, I think, about 7 years by now. It's been created by Thomas Hodden 7 years ago, and since then it grew up to be, I think, the biggest and most important 6D pose estimation benchmark for the research community. Usually, if you work on some novel method for 6D pose estimation, you need to run your method through this benchmark and get the metrics for your method. Otherwise, you likely won't be able to even publish it, because this is like the key way to understand where you stand against other solutions out there. So if you go, for example, to the BOP website and go to the leaderboard, here you can see all the various methods benchmarked against each other on some of the data sets that BOP has open sourced here. So BOP is partnering with us on running this challenge, and BOP also runs the challenge for 2025, which is basically the challenge targeted on research community. You want to participate in BOP if you want to publish any novel method related to pose estimation. And this year, BOP also introduced so-called BOP Industrial, which is focused on industrial parts and higher accuracy pose estimation, which is exactly also a BPC challenge goal. Since we're partnered with BOP, we share the same test dataset for the phase 1. This IPD dataset mentioned on BOP website is exactly the dataset that is going to be used for the phase 1 of our challenge. And you're welcome to submit your solution both to BPC challenge, the one that we're running, as well as BOP benchmark. If you want your metrics to be available for everyone, and if you want to publish your solution, you're welcome to submit to BOP challenge as well.
Great.
Yeah,
So,
and
Vahe, at this
importantly,
point,
if you go ahead, Satya.
So at this point, it may be useful to know whether traditional BOP data set, right, until 2024, what is that data set and how is it different from the data set that Intrinsic has released, the IPD data set?
Yep. That's a great question, Satya. So BOP is not collecting data sets themselves. I'm not even sure how they're classified. They're probably not a non-profit organization. They're just basically an organization that help running these benchmarks. It's just a group of enthusiasts, basically.
Yeah.
And they use the open source data sets collected and published by other groups all over the world. So they use multiple data sets in their benchmark. If you go to the dataset section of the website, you can see the data sets that have been used so far by BOP. There are multiple key differences between what's been so far used by BOP as like the core data sets and what we have with IPD. The core difference number one is that this pose estimation problem is not just robotics problem. It's also often used for augmented reality and just like general computer vision. So up until now, most of these data sets were focused on like regular household objects. Usually these objects are highly textured, simple shapes, not super reflective. Basically, they're easier to detect than industrial shiny objects, like I don't know, a screwdriver or like some piece of metal with a weird shape. So the types of objects used in BOP Classic are different for most of these datasets, are different from like regular industrial objects. That's the key difference number one. Key difference number two is the accuracy requirements between the regular AR, like augmented reality applications, and robotics are also very different. For robotics, you want to have the accuracy at the level of ideally sub-millimeters, but maybe like a couple millimeters. And for augmented reality, you can go with like much higher error rate. And then finally, one of the key differences introduced also by BOP in the recent datasets is that now they support multimodal and multi-view datasets, and this is super critical for our challenge and for IPD dataset as well. Basically, for robotics, it's very common to have multiple viewpoints. You would have like multiple cameras, and these cameras can be like regular RGB cameras. They can be depth cameras. With IPD, we also introduced polarization modality for some of these cameras. So it's very typical to have these multiple viewpoints, and this is like novel for BOP datasets as well. So this is like another key difference of the IPD with like the datasets that were used previously at BOP.
Yeah. And the novel viewpoint would be that you have an object and there are multiple cameras looking at that object so that you get multiple viewpoints and you have a very good idea. And these cameras are calibrated among themselves. So you know it's not just a single view that you're using to find the pose of this object, but all the views. And then multimodal means that one modality is obviously RGB image, but then we have other modalities. For example, you could have the depth information also. So all these cameras could be depth cameras, or some of these cameras could be depth cameras. Another one could be that you have this polarization. So so you can actually put polarizing filters on these cameras so that this shininess, these objects are very shiny sometimes, right? Industrial objects, especially if you put a polarizer and the light is also polarized, then the shininess becomes less, right? You can arrange it in such a way that it is not as shiny. And there could be other modalities also that I'm missing right now. But that's why could you confirm that what I just said is about right? Because I'm not into robotics as much.
Yeah, Satya, you're right. It's basically about having multiple cameras in the scene.
Yeah.
As you said, they're perfectly calibrated to each other, so we know the positions of all the cameras, and they're looking at the same objects and they're capturing the information at the same moment of time. So basically, you have the same objects captured from different viewpoints. These cameras have RGB and depth. All of the cameras in the challenge dataset have depth and RGB supported. And by RGB here, we mean actually grayscale images. So we don't have a real RGB. They're
Okay.
all monochrome, but we call them RGB.
All right.
And then also for 3 out of 4 cameras, like IPD dataset, the challenge dataset has 4 cameras. For 3 out of these 4 cameras, we also have the polarization. You're absolutely right saying that the shininess of the material often polarizes the light, and you can suppress this shininess. But we also go one step further. It's not just about adding a filter on top of the camera, but we have multiple apertures with multiple filters. And when we combine these images, we're able to reconstruct both the angle of polarization and degree of polarization of light reflected from the object.
Interesting.
So it's like one step further than just suppressing the glare.
Got it.
And we don't control the light, so we don't shine the polarized light there explicitly, but we do have some scenes captured with daylight, and daylight is usually like quite polarized. We have like various lighting conditions in this data set as well, and this is, by the way, also something somewhat different from the previous data sets used at BOP. In the industrial settings, you would always have, like in the factories, you would have either some darkness or certain spotlights coming from different directions, or maybe sometimes direct sunlight coming from the window on the roof. So you need to be able to build solutions that are very robust to very different lighting conditions. And we tried to emulate that to a certain extent with this IPD dataset. Participants can see, once they download the test data, they'll see that the images are captured in a very different lighting conditions, sometimes very extreme and challenging lighting conditions.
Right.
Yeah, so going back to BOP, again, we encourage all the participants, once they develop their solutions, to submit the results to BOP as well. BOP, as far as I know, is not giving any prizes this year, so they're partnering with us to organize BPC, and they don't to provide any prizes on their benchmark. But you still, if you want to be on that leaderboard for years, if you want to have your solution benchmarked against all the state-of-the-art research solutions, you're welcome to submit to BOP. And the best solution in the BOP benchmark, BOP 2025 benchmark, will also have one spot in the CV Power workshop to present their solution. Going back to the challenge website, so as many of you already seen, you have this bright participate button. Once you click it, you go to the challenge page, which describes everything you need to know about the challenge. I'll go through some of the key aspects where you need to get the data, how the test submission looks like. But I just want to make sure people know that all the information I'm covering today is also present in this challenge overview section. In the phases section, there is this phase development that we're currently running. All the links I'm going to present are also available here. So you also can, like, once you read everything, you also should have a pretty good understanding of how the challenge is going to run.
Yeah, and speaking of how the challenge is going to run, maybe now is a good time to, before we talk about the specifics, go over the timeline briefly. Shall we do that?
Yeah, that's a great idea. So there are 3 phases that we have planned. The phase that we call phase number 1, phase development, is the phase where you're supposed to develop your solutions, develop your pipeline for the test parts that we provided. And I'll talk about these parts as well as the data set for the phase development in a bit. But this is the phase where you just basically prepare your pipelines, and you're welcome to submit the solutions to the challenge website. You'll be ranked on the leaderboard. However, it's very important to note that the final leaderboard won't be based on the phase development solutions and the phase development metrics. This is mainly for you to make sure you develop your solution in the right direction, and for you to be able to benchmark yourself against others who also participate. We open sourced all the data for the phase development, and I'll talk about that in a second. So phase development runs from February 11th till April 20. This is the time within which you'll be able to submit your solutions and get the metrics on the leaderboard. The phase testing is the phase which will be actually used to create the leaderboard, to rank the solutions against each other. And the key difference of phase testing with the phase development is that here we won't release the test data. So you won't see the actual data with the parts. We will release the parts though. It will be a different set of parts, 10 new parts that you'll need to train your models for. And we will release the training data for phase testing. So you'll have the training data and the actual parts that you need to be able to detect, but you won't see how the test data looks like. This is to make sure there is like no cheating and the ranking is as fair as possible, as well as the solutions that we rank are like generalizable. They're not just overfit on these 10 parts that we use in the phase development. So the phase testing is going to run from April 20 to May 1st. And the idea here is that you'll have just one chance to submit. We may reconsider this and give like 2 or 3 chances to submit in case we see there are like certain issues with the bugs in submissions or something like that. But there will definitely be a very limited number of submission opportunities for phase testing, so that you won't be able to kind of optimize on your test data sets. You won't be able to tweak the parameters until you get the best metrics on test data sets. This
Or
is
in gamer terms, you won't be able to cheese it.
exactly. So consider test phase being you being deployed in a real factory. There is no time to improve your solution any further. You've built your solution already. It's time to test it on new parts in the factory. This is what test phase is. And once we have the teams ranked on the phase on the test phase, the fun part of the challenge begins. The phase which we call robot in the loop testing, where we're actually going to take the solutions prepared by the participants, and we're going to deploy these solutions on a real robot using intrinsic flow state. This is the product of Intrinsic company where work at. So we're going to use flow state to deploy the solutions by the participants, and we're going to run a real robot on these parts from phase testing, and we're going to try to pick these parts with the robot arm using the poses detected by participants. And the final ranking of the challenge is going to be based on this robot in the loop testing. We're going to basically compute the number of successful grasps. We'll talk about like how specifically we're going to measure that in the coming weeks. But basically, we're going to evaluate how successful is the solution the participants built in actually grasping the objects, or like helping the robot to see where the objects are, so that the robot can grasp them. And that's going to be the metric that will be used for the final ranking in the challenge. Participants won't need to do anything for this robot in the loop testing. We'll just use the solutions submitted to the phase testing directly. That's the magic of intrinsic flow state. We'll be able to just deploy the containers into the flow state and use the detected poses. But I think we'll stream these attempts, like robot attempts to pick the parts. We'll show everyone how this looks like, how the grasping looks like, and how important is it to be able to detect the poses accurately so that the robot can grasp the objects. This robot in the loop phase will run in May. We expect it to end around May 20, and then we'll make the results public. And then in June, we have the CVPR workshop, where 2 of the best teams presenting from the challenge will be presenting their solutions to the research community. That's
Will the sessions be? I know we'll have to go through legal and everything, whether we will be able to record these sessions where the robot is actually picking up. But we'll see. If possible, we'll do it.
Oh, if at all possible, we will absolutely live stream that and watch it with popcorn. Yes.
exactly that's also what I would like to do. We will need to go through the legal there.
Yeah.
But we'll try to make it happen.
But
We'll have to,
there is also this
air
other
gap some
issue,
stuff,
right?
yeah.
There's the second issue that the actual estimation of the pose, it's not real time, right? We don't require it to be real time. So it can take, I don't know how much time it takes per, some of the solutions which are actually good could take a long time, right? Like in 5 minutes, it does the pose estimation and then the robot goes and picks it up.
So
It'll be like watching the DVD screensaver to see if it hits the side of the corner, right?
yeah, it's a very good point, Satya. And actually, there is a constraint on the runtime which we use in the challenge. So it takes time to detect the poses, but I don't think participants will have 5 minutes per scene, because
All right,
one of the
total.
constraints of the challenge is that you need to be able to detect all the poses for all the scenes in the test data set in 12 hours, and there are like 1,200 scenes there.
Okay.
So you better detect the poses in like 10-20 seconds per scene,
Okay.
otherwise you won't fit the time constraint.
Got it. Got it. Yeah. So that simplifies things, right?
Yeah. It's always fun to watch robots moving, so I hope we can organize that.
Especially if next time when everyone listens to me and we give the robots knives.
Luckily, they're in a cage cell, so even if they have knives, they won't.
And they're not mobile robots, so you
So
can
far,
fight all
yeah.
you want.
They're just gonna rage. They're just gonna rage in the cage with knives. Yeah, that sounds fine. Sounds fine.
Man, sometimes it's scary to enter that cage even when you know that the robot is turned off. But like, I don't want to give them knives. All right, so this is a brief overview of the phases. Again, this is the question that we received already multiple times. It's important that people understand that there is this phase testing that they need to keep in mind. That's why it's very important to build the solutions right now that are generalizable, meaning you have the same pipeline that works for all 10 parts, and you're not trying to overfit on a single part, having some tweaks that will work with like uh, round shaped parts or parts that look like gears. That won't really help you because the main ranking will be based on phase two, which will have different parts. And all of these tweaks will actually hurt your solution instead of helping it. So it's better to just build the generalized pipeline that you just give the parts and it like trains one model or multiple models and learns how to detect their poses.
Right. Right. So basically, look at the entire data set. The pipeline should be you have built a black box. You looked at the entire data set, and out comes the result. Instead of saying that, oh, inside this black box, I have this circle detector, which is detecting circular things because I know that two of the 5 parts are circular or things like that, right? So because those parts will change. So you have to look at general solutions.
Exactly. I guess it's a good time to talk about the data for phase development, right? The phase
Yeah.
one of the challenge.
Yeah, I
So
think so.
all the data for the phase development is open source. It's publicly available. It's available at Hugging Face at the BOP benchmark /IPD repo. And there is this short instruction on how you can download it. You can also use the Hugging Face CLI to download it. You can also just wget it and unzip everything. So there are multiple files here, and I want just to go quickly through all of them to explain what's going on here. The there are key part like there are key components of the for each data set. There are first of all the 3D models of the parts that you need to detect, and all of the 3D models here are available in ipdmodels.zip. So there are 10 3D models. You'll see 2 folders there. One is called models, another is called models eval. You can ignore models eval and just focus on the folder called models. And there are 10 PLY files. You can open them and see how the actual 3D models of the parts look like. They have the right scale in millimeters, so their shape and size is correct. You can rely on that. These are the parts that you'll need to detect. Now, we also generated some training data with these parts. The training data is basically a synthetic data with these 3D models randomly placed in the world with random poses, rendered from multiple viewpoints. And all these renders also contain both grayscale image and depth, plus also ALP and DLP from 3 viewpoints. So basically, in the training data, we tried to emulate the real scenes as much as possible. The training data is available here. Actually, just heads up to everyone that we're generating more data. Generating data takes time, especially when you try to do it photorealistically and when you also use all these additional modalities. So we'll continue adding more training data over time, and we'll keep notifying people once more training data is added. People are also welcome to generate their own training data. We won't limit people in any way. If you think there are gaps in the training data we provided, and I'm certain there are, you're more than welcome to generate more training data, add like more augmentations to the training data, and use that to train your pipelines. This is actually usually a very important piece of any pose estimation pipeline. And like in general in machine learning, your models are as good as the data is. So we're encouraging people to be critical to the data we provide and generate more if you feel there is like necessity for that.
So these files basically you can load all the material information as well as the 3D structure information is there in these files. You can load it in any 3D modeling rendering tool and render it. Is that correct?
So the files you're talking about, Satya, are the 3D models in
Yeah.
ipdmodels.zip. These
Yeah.
are 3D models without the materials. They just
Okay.
contain shape, and that's it. There are no materials, but yes, you can open them with any 3D modeling tool. Like you can open them in Blender, in MeshLab, in Cloud Compare, anything you're used to. They're like
Right.
regular PLY files, regular meshes, basically. And the training data is just like images, depth maps, ALP, DLP, like angle of linear polarization, degree of linear polarization images. So the trained data set looks almost exactly like the test data would look like, except that the trained data is synthetically generated. So these are just synthetic images, basically.
Got it.
And they're generated using these models.
Right. But all the test data is real images, right?
Exactly. Yes. All the test data is real images. So the train data has all the ground truth poses for all the parts, obviously, because you need to be able to train based on these poses. And the test data doesn't have these poses available. Although, to be fair, there is small subset of the test data called IPD-val. This is so-called validation data set. And this is the subset of overall test data of these real scenes captured with real cameras. Which also has the ground truth poses labeled. So these are the ground truth poses that we annotated ourselves. And we have them there for the people to be able to run the pipelines before submitting to compare what poses you generate to what we have in these validation data sets. So basically, as you have in like various machine learning pipelines, right? You have the validation data set that you can use to evaluate your solution. You can try to optimize maybe a little bit on the validation data set, but then you also have the test data set for which the ground truth is hidden, and this is like the actual submissions will be tested on this test data set. We
Right.
release this data for people so that you can see how the data looks like. You can play with it. But again, I really encourage people not to overfeed too much on the test data, because the data that will be used to build the final leaderboard on phase testing will be a different data on different parts, and we won't release the test data for that data set.
Right.
So this is just for people for their reference to run their solutions, maybe to visualize the poses they predict and render them over the real images to see visually how the parts aligned. And also to understand what is the structure of the data, right? How the data set is structured, how does it look like how the files are structured, where is all the data. And this is, by the way, an important point. All the data is structured according to BOP standards. So there is a special BOP file for dataset format, which can be loaded automatically using BOP toolkit. And all of the data sets are structured according to the BOP format.
Right.
So, Satya, you want to say something?
I wanted to say that there are some people who are obviously many people are participating to win, but there are many people who are participating to learn. Right? They are looking at this challenge for the first time. They are looking at this problem for the first time, and to them, I would suggest that just going through this data, right, running the reference implementation and getting one solution out, that get started with that, right? I mean, you will learn a lot about various aspects of the problem, even if you are not in the on the leaderboard and doing great. This could be a learning experience. Take this 2-3 months as a solid, you learn everything about this problem in a short period of time, and it opens up doors for you because suddenly you are one of the few people in the world, right? Let's say you are among the top 5,000 people in the world who know at least something about this kind of a problem. And a lot of robotics companies, and there will be plenty, there are plenty now, and there will be plenty in the future. This revolution is just starting. For you, it could be, almost a launch pad. Even if you don't win, right? This learning about this problem and how computer vision and robotics, these problems are intertwined, you'll gain a lot of experience.
I fully agree. This is a very important comment, and I think, like for me personally as well, participating in the challenges was one of the best ways to learn something. We also encourage people to be active on Slack in the forums, maybe share some of the like intermediate solutions that they built with the community, because that helps others, that helps you to get feedback. It's much better to do it that way than like hide everything. And
Right.
that's one of the reasons why we also built the baseline solution, which I'll talk about in a second. But just before I talk about it, I just wanted to share this quick video showing 4 of these 10 parts that are going to be used in this phase 1 of the challenge. So as you can see, these basically are regular industrial parts, like gears, brackets, this oblong float, this dark part called oblong float is actually quite tricky. So I'd be really curious to see how people solve its pose detection. These are just 4 examples. There are like 6 more parts in the phase 1, and the parts in phase 2 will be some other industrial parts. But just like for you to understand what are you going to deal with. Now, let's talk briefly about the submission process. We have this repo called BPC in the OpenCV GitHub account that we built to show you how the template submission should look like, how the submission is going to be tested on our server, and just to give you also some baseline implementation, some references here. Most of this code here is not directly relevant to the participants. We still encourage people to just go through the README here. I think it's fairly well written. It explains what's going on here. Just for people to understand, this is the code that is going to be running on the evaluation server. So every time you submit your solution, it's going to be evaluated on a separate instance. And by the way, this instance won't have any internet access, so don't try to download the data from our servers when you when you submit your solutions. So this instance will run the evaluation for your solution, and the way the evaluation is going to run is you're going to implement a part of the service that will get a query with the scene description, which is basically camera information, like the poses of the cameras, images from these cameras, and which parts should you be looking for in that scene. And then this service expects you to return the poses of these parts. We have this IBPC pose estimator Pi directory here. And if you go to the IBPC pose estimator Pi script, which by the way, the first line is import CV2.
Love to see it.
The key part of this script basically is this get pose estimates function. And we expect the participants to implement the internals in this function, like basically to implement the function that will return the poses. So basically what you need to worry about in this whole repo is just this piece of code. And then you obviously can add your own models, your own files here, but you don't need to worry about anything else in this repo. All the other code there is just for your reference, for you to understand how exactly the evaluation is going to run. As Satya mentioned, we also have a baseline solution. This is basically a simple, very simple solution that shows how pose estimation can work, which we implemented together with the team from University of Hawaii. Graded students from there just spend their time implementing this baseline solution for us. And by the way, they continue improving this baseline solution, so you can pull the updates from this branch from time to time. So if you go to this baseline solution branch, you'll see a simple implementation here. And you can use this implementation as like a starting point for you, or you can just run it and see how we expect the submissions to look like. This is basically for your reference. So in this repo, we have this IBPC pose estimator.py. Again, this is the part which we expect participants to change. We also have the tester. Tester is basically our piece of code that is going to be querying the get pose estimates function with new scenes and get the predictions from the participants back. This is the service that is going to be running on the instance that will be evaluating the solutions. So if important point here for people to understand is that we expect people to submit the containers that will have all the models and all the like basically the inference code running inside the container. So it basically has to be a service that will be accepting queries with the scenes and returning poses. Important reasons why we do it that way is to make sure that we can run the robot in the loop phase, that we can use the same container and run it with the real robot, and that we can also evaluate the solutions on the hidden data set in the second phase, in the testing phase of the competition. So that's the reason why we require people submitting the containers with their solution. And I think if all these things are novel to you, you can go through this documentation. It describes everything in a lot of details and like how exactly you can build the containers, how to run the baseline solution, just like getting this hello world kind of solution for the challenge. That's briefly about the baseline solution. Shall we briefly talk about the intrinsic flow state and the workshop, or is there
can we pause a little bit and ask if somebody has any questions about this part, but because this is important, we can answer right away.
Yeah, we've got quite a few questions in the Q&A if we want to take a look here. So starting with Bruce, we got Bruce right here would like to know, so the robot testing is with 10 new / different objects. Will their 3D models be usable somehow in the testing stage?
That's a great question. So I guess what Bruce means is, would you be able to use the 3D model during the inference time, not during the training, but also during the inference, whether it's with the robot or in the phase 1 or phase 2? We're allowed to do that. We don't explicitly provide the 3D models in this service, but you're welcome to use the same 3D models that we have, like that we provide with the dataset. You're welcome to just add it to your container and use it during the inference. If you want to do some refinement of the pose or something like that, you're welcome to use these 3D models during the inference.
And even with the phase testing, in the testing phase also, these 3D models will be provided, so it is perfectly fine.
We'll definitely provide the 3D models much in advance the test phase. It will happen within the next few weeks, actually, so that people will see what the test phase 3D models look like. And people will be allowed to use these 3D models during the inference.
That's very interesting. I had not thought about it.
We've also got Philip Ha would like to know, during the development phase, will each submission return test results, including the precision / recall and MSSD?
Great question. We'll actually talk more about the specific metric we're going to use in this challenge in the coming weeks. It's going to be MAP on a set of threshold from SSD. So it's going to be basically a single number in the end. It's not going to be like precision and recall and like MSSD. It's going to be a single number based on different thresholds of MSSD, but we'll share the exact equations and the code for computing this metric in the coming days, actually. One thing for people just to focus on right now is just try to get the poses as accurately as possible. Metrics are important, but they're not super important to worry about. Your goal is just to get the poses as accurately as possible. That's basically the main goal. But again, we'll talk in much more detail about the metrics in the coming days.
Excellent. Thanks for that. We've also got quite a few folks asking about the data, such as what will be provided in terms of how it was captured or generated. They're asking, will this data be RGB, RGBD, stereo? I think you've talked about this a bit, but maybe a bit more explicit on this answer.
Yeah. So There are 4 cameras in each scene. Wait, I think we're talking about the real data, or are we talking about the generated data, the synthetic data?
I believe the real data.
Okay. For the real data, we have 4 cameras that are used to capture the data. And by the way, we're going to use the same 4 cameras for the test phase, and same 4 cameras will be inside the robot cell during the robot in the loop phase. So the setup will be the same for all 3 phases, so that people won't need to change their solutions in any ways during these phases. So we have 4 cameras. One camera is a PhotoNeo camera. It's a 3D sensor that is capturing grayscale image as well as depth map for a single viewpoint. And then 3 other cameras. So PhotoNeo is a structured light camera. I guess it's important to mention that PhotoNeo is a structured light camera. It has a pretty good precision. The accuracy can sometimes be a little bit off. And there is also an issue that is certain depth maps are not super complete if you have shiny surfaces. That's a typical problem with like shiny surfaces. You can have like huge gaps here and there. So keep that in mind. Then we have like this is 1 out of 4 cameras. 3 other cameras are so-called IPS cameras. I think I shared in Slack the link to the paper that describes what IPS camera is. We can also put that somewhere on the website, I think. Basically, this is a stereo camera that is able to capture polarization data as well. However, what we provide to participants is already post-processed data from IPS, which is basically we have 3 cameras which are located at a distance of about 1 meter from each other on top of the scene. So all of these 4 cameras are looking down at the scene. And these 3 IPS cameras, each of them has depth map, which is computed using like some deep learning stereo algorithms, as well as ALP and DLP. So you have just a single grayscale image per camera, single depth map, which is a stereo depth map, single polarization angle of polarization image, and single degree of polarization image. And then you have 3 of these cameras, IPS cameras, looking top down.
So that's nine images for these three per image, right? So you have the
It's not per image. It's RGB, depth, ALP, DLP.
Okay.
So it's 12 for IPS and then 2 more for PhotoNeo. Basically, for every scene, you get 14 images.
Okay, got it. Okay.
Serious data here, folks. Noe would like to know, in this pipeline, is image segmentation and detection done for us, and they only need to focus on pose estimation?
No, great question. Segmentation and detection are also part of this challenge. So this is like different. There are different solutions solving the pose estimation problem differently, and some of them do require having this detection phase coming first, but not all of them. So we do give the participants the opportunity to just build the pipeline end to end themselves, and we don't provide any information on where approximately the parts are. The only information about the scene you're provided beyond the images is which parts should be looking for, like the IDs of the parts that are available in the scene. However, we also won't tell how many parts are there in each scene. So you'll need to like somehow rank your detections on your own.
Right. And in the scene, there could be multiple parts. Are they separate parts, overlapping? We don't know.
So parts are somewhat sparsely located, but there can be a little bit of overlap from certain viewpoints. There can be a little bit of occlusion from certain viewpoints. So people should keep that in mind. But this is not a clutter setup. We don't have parts on top of each other. They're like somewhat singulated. And we can have multiple instances of the same type of part within the scene. So basically, and not only can have, we do have. Every scene has multiple instances. So let's say we have we tell you that you need to look for that oblong float part or like certain gear, you can safely assume that there are like multiple instances of that gear in the scene.
Right.
We've got another one here over on YouTube. Newton would like to know, First of all, shout out to Sir Isaac Newton. Big fan of your theories, bro. So they were wondering if they can. Will we be for the real test, the real challenge? Will we be providing the focal length or principal point of the camera, or will that be kept secret from participants?
We do provide all the intrinsic and extrinsic parameters of the camera. So focal lengths, the principal point, the images are all undistorted, so you don't need to worry about the distortion. All the extrinsic parameters, meaning the position of the cameras with respect to each other, all that information is available. The cameras are pretty well calibrated, so you can rely on that data.
We've also got a question here from Zoom. Do you have any suggestions for, say, minimum CPU, GPU specifications in order to run this challenge and participate?
Oh, that really depends on the solution. There are solutions that can be developed that don't use GPU, but they're likely to be not the leading ones. It really comes down to like how exactly you implement your solution. So for the evaluation, we do use the L4 GPUs from NVIDIA, which have 24 gigabytes of GPU memory. So that's something participants can rely on their inference. But for training, it's really up to the participants.
Got it. I think so. We actually just dinged 10 o'clock. I think we should do our giveaway here before we continue with some flow state and then some more Q&A. How's that sound, Vi?
Yeah, that sounds great.
Cool. Go ahead and do me a favor, unshare your screen right quick, and we'll do our giveaway.
Yep.
Thank you very much. And thank you, folks, for sticking with us. There's a lot to cover on this one, and you all are providing a lot of really good questions, and we want to get to as many of them as we can, so I will be brief. One of the things we do on this show every single episode is give away something to you in the audience. Today, we're going to give away the OpenCV course of the winner's choosing. This is our trivia competition. One question here in the Zoom chat with your messages set to go to everyone. The first person to answer the question I'm about to ask in that chat will win the OpenCV course of their choosing. If you are not in Zoom, you can try to get there really, really quickly by going to opencv.live in your browser. It'll bounce you over into Zoom. We currently do not do trivia for the other chat systems because there's a little bit of delay and it just wouldn't be fair. That may change in the near future. This one is going to be a two-parter. We've talked quite a bit about BOP and the BOP challenge, the BOP toolkit here today. We are indebted to them for the past many years of really cool challenges and what they provided for free. Pre-BOP challenge, there was another title for the same challenge. Before they published the BOP paper in a few years ago, there was a previous challenge. What was the name of that challenge and what year was that challenge held? Pre-BOP challenge. What was the name of it and what year?
Oh, that's a tough one. We're not getting answers.
I'm making them think today. Y'all made a fool of me last week. I had to double down, you know. Reese Leclerc says 2005 DARPA Grand Challenge. Good guess, but no. I have used that one a couple times. Oh, there we go. Looks like Joel Adebio. Sorry if I butchered your name there, Joel. The correct answer was the 6D Challenge in 2017, 6D Talent Challenge 2017. That, of course, preceded the BOP paper being published in 2018 at ECCV. So congratulations, Joel. Please send one email to phil@opencv.org with the name of the course you would like. You can see what courses are on offer by going to opencv.org/university and taking a look there. Pick a course, send me an email. We will make sure that you get it. Let's continue on. We've got, I think, the best thing to do right now, Vahe, would be to go ahead and talk about flow state. I'm interested to hear about this incredible tool from Intrinsic.
I think you're on mute.
I just realized that I'm muted. Yep, sorry for that.
Welcome back.
Thank you. I'll just briefly share the Intrinsic website. people are welcome to visit the website and go through the platform in more detail here.
That's
What else?
intrinsic.ai.
Thank you, Phil. Exactly. And here, if you go to products intrinsic flow state, you'll be able to learn more. Flow state is a platform for industrial robotics that helps to simplify building the solutions for industrial robotics. I won't talk much about how the platform looks like or like how it works, but I'm really hoping to be able to show more about flow state at phase 3 of the challenge, because that's where the power of flow state will be used in full. Just like taking these solutions built by participants and deploying them directly in the robot, like in the real robot pipeline, is one of the like magic pieces of flow state. One of the things flow state enables easily, and this is something that was not that easy to do before flow state. So that's why flow state basically enables us to run this challenge. But I'll let the participants to just go to the website and learn themselves in more detail about what Intrinsic is doing and how we help moving forward and democratizing industrial robotics.
Yep, that's intrinsic.ai. Check out flow state.
And I guess one more thing we briefly want to talk about is the CVPR workshop, which we've built a simple website for. This website is not public yet. It will be public in the next couple of weeks. The website is called pira-workshop.github.io. So for those who don't know, CVPR is Computer Vision and Pattern Recognition Conference, probably the biggest computer vision conference and like one of the biggest machine learning and AI conferences in the world. It has like last year it had 10,000+ attendees. It's basically a huge event for all the computer vision enthusiasts all over the world, and it's a top tier conference, meaning it's very hard to get papers published there. Only like people submit their best works there, and out of the best works, only about 20 to 25% of the papers actually get accepted. And out of these 20-25%, only few percent have the chance to present at the conference. So, and this is the great part about this challenge. As a challenge, we also had a chance to we got accepted to organize a workshop at CVPR, and we have a chance to give the winning teams the opportunity to present at this workshop, to present to a very wide audience of computer vision enthusiasts how their solution works, what are like the key novelties there, basically get some attention from like the key computer vision audience.
And it looks great on your resume.
Exactly. So besides the presentations of the participants, there will be some very famous computer vision, machine learning, and robotics experts talking at this workshop. So we're also welcoming people to just like attend CVPR and attend the workshop. And we already have a schedule here, so you can just go to the website and learn more about the workshop. But again, just to repeat, the two winning teams from the challenge will have the opportunity to present at this workshop, which is, I think, an amazing opportunity. That's it from my side.
Yeah, fantastic. Yeah, Satya, pitch the folks on what a big friggin' deal this CVPR workshop is for them specifically.
I would say that if you publish in this workshop, right, this would be career changing for you, right? It will get the, all eyes are on for robotics. The people who are working at the intersection of robotics and computer vision, right? This workshop would be one of the things that they would be looking forward to, and how people do, who are the people who get selected in this workshop. I also want to give one little anecdote that people should keep in mind while participating. So some of you who are very talented and who are very hardworking, etc., but may be feeling that, okay, these people have been working on this kind of thing for the last 5, 6, 10 years. Some of these groups have been working. How do I beat these people, right? What are my chances? So an anecdote or a story that I like to tell here is the 4-minute mile challenge, right? This was a challenge that people thought that it was not humanly possible to cross the 4-minute mile. And there was a grad student, a medical student, who basically used to, he did not have a very rigorous training regimen. He was very smart about it, but he used to spend 1 or 2 hours every day preparing for this. And this guy's name was Roger Bannister, not a professional athlete, right? He was doing this on the side while preparing for while in grad school, and he was the first person to break the 4-minute mile, right? So you can look up the story. It's fascinating because the next year, something that was impossible, something that was considered impossible for 3,000 years, somebody broke it. And then in the next 1 year, there are several people who broke the 4-minute mile, right? So that is what we are expecting here also, some new idea that comes along, and it shakes up how people traditionally do things, right? And we saw that in ImageNet Large Scale Visual Recognition Challenge also, where the challenge was released in 2010, and 2012 is when the major breakthrough happened. It just shook the computer vision world. So so basically, give your very best. And what we are hoping for is among the 10 teams, if we can get 2 new teams, right, 2 new entrants with 2 new good ideas, that would be success for us, right? And in the best case scenario, if we are able to beat Intrinsic's internal implementation, which we do not know, this is not the baseline solution is obviously not Intrinsic's internal solution. But if that happens, you sure will get a call from somebody from Intrinsic, you know. uh, and
Yeah.
yeah, so that could be a very big deal as well.
Yeah, definitely. We've got a ton of questions here. I'm going to try to filter some of these down here.
There are 10
Vahe,
prizes. That's why I mentioned 10 teams.
yes, that's right. Do we have a timeline for when certain data will be available, like for example, the camera parameters as we discussed earlier?
All the camera parameters are already available in the dataset. So once you download the dataset, you can see that there are files called scene camera and then the camera name, like cam1, cam2, or photonia. These are JSON files that have all the camera parameters there. So all the data needed to build your solution for phase development is already out there. You're welcome to start building the solutions.
Right.
Great. We've got another question here. Up to now, how many participants have registered? I just checked, and we're at 980 registrations
But
here.
how many teams are there?
Teams, I have not looked, but I am on the page right now, so I can do that. Let's take a look. API. Okay, teams. It looks like there are 245 participant teams right now. 245.
Right.
So yeah, good
And
luck out
also,
there, folks.
there is one thing that I just want to warn you about. Most of the people will not be cheating, but please don't do things like create multiple accounts to participate so that you can submit multiple times, right? Don't do those kinds of things. It's obvious, but it is perfectly fine. Somebody said DeepSeek R1. Yes, go ahead and use ChatGPT Pro,
Yeah, why not?
DeepSeek, whatever you want to use to solve this problem. All of those are valid. You don't have to hand code any solution. You don't have to come up with your own idea.
This
If you
is
can
like,
get,
yeah, this
yeah,
isn't a John Henry challenge yet, I don't think.
right. So yeah, all those things are fine.
Yeah. Another one here. Does the second phase of the competition use parts previously seen or totally new parts from the first phase?
These will be completely different parts from phase one, meaning there'll still be some industrial parts. They'll have approximately the same size, similar material properties. Some of them will be like metal-like brackets or stuff like that, but they'll be different parts. So none of the parts from phase one will be used in phase two. However, these parts, like the 3D models for these parts from phase 2, will be given to the participants in advance, like at least 1 month in advance before the phase 2 begins. So you'll know what parts are used there. It's just that you won't see the test data for these parts. So you won't be able to kind of overfeed on these parts. You'll need to build a generalized solution, or like a generalized pipeline that you just give these CAD models, train the models, your neural networks based on these training data, and get the pipeline ready working for the new parts.
Are those parts a part of the 22 in the initial IPD dataset or not?
No, that's a great question, by the way. People who expect that we'll use parts from initial IPD dataset should not expect that. So we picked these 10 parts for phase development from the initial IPD dataset, and this is like the initial IPD dataset is basically this phase development, and the phase testing, like the second phase, is newly collected. No one except me has seen this data, so and these are new parts.
Great. And also, one other thing that people may be, you could actually go and look at the BOP challenge, and if you find a solution which somebody had previously posted, let's say it is an open GitHub repository, it is perfectly fine to build on top of that, right? You could actually beat the team that actually created the original solution if you optimize on it, do whatever, right? So that is also any publicly available solution that you build on, that is perfectly fine too.
Yep.
Excellent. Let's take a look at our questions from YouTube here. I think we've got a few. So a few people were asking, and I think this is something that Satya can speak to really well here. OpenCV has done many competitions over the last several years of a much different kind than this one. So people are wondering, why are we doing this new type of competition with these, kind of this very technical submissions and leaderboards and things like that? Satya, can you talk a bit about that?
Yeah, so in the previous challenges, right, our main goal was to encourage people to do computer vision, right? Just people who are starting out in computer vision, etc. But then we found an opportunity where with Intrinsic, that can we actually push, right? Can the community push the state of the art, right? And those are two different kinds of competitions, and we don't want to restrict ourselves to, it's only for growing the size of the computer vision community. We also want to push the state of the art. So this was just a different mindset, and we are experimenting with it, so to speak. And we, if you get a chance to work with people like, smart people from Intrinsic and BOP and University of Hawaii, you don't say no to that opportunity, right? So, and I would love to see that we are, as a community, we are able to push the state of the art. And if that happens, we'll get more of these challenges.
Yeah, absolutely. It's all about OpenCV using the cachet that OpenCV has to give you free stuff. That is what we do. That is what we do here. And form these great partnerships and have the opportunity to bring you these shows. Like, it's all part of the same big ball of wax, and that's a big part of why we do this stuff. All joking aside, is because I think everybody here on this show currently, especially, really does feel a strong bond with this community and wants it to thrive and continue to be relevant and a great place for people to get started and to share their research once they're in the field. And so that's why we do this stuff. We've got a couple questions here about, so this is technically, I guess, a 2-track challenge. There is the sort of main path, and then there's also the prize for the best one-shot solution. We've also got seen and unseen objects. So people, I think, are a little bit confused about the phases, perhaps. And so, Vahe, can you talk a little bit about why it's a bit different to have the best one-shot solution versus the best general solution?
Will do. I think Phil, you're also referring to the question about the web page with several tracks, right?
Yes.
I think it may be also some confusion with the BOP and BPC, which is
Yeah.
the names are also not helping here.
See.
Basically, just to repeat, the main challenge website is bpc.opencv.org. The beam picking challenge is running there, and there is one main track. Like there's going to be just a single leaderboard. It's just that we're going to give a special award to a one-shot solution. By one-shot solution, we mean a single pipeline which works for all 10 parts in the same way. So there are no specially trained models for every part, and you're able to just like have the single model or like maybe multiple steps in the model, but basically a single architecture for all the 10 parts. This is what we call a one-shot solution. We believe one-shot is a very exciting track in the future, and it's very likely that the future solutions will be fully one-shot. That's why we wanted to have this special track for one-shot solutions. From what we currently see, usually the solutions that are trained per part perform better than one-shot solutions. However, we didn't want to discourage people developing one-shot solutions from participating. That's why we created the special prize for one-shot teams. If you're developing a one-shot solution, please add one-shot to the name of your team so that we'll know that your solution is qualified to be one-shot. And we'll obviously double check once we have the final ranking. We'll obviously double check whether the winning team with that one-shot node does actually build a one-shot solution. But if it does, there is a special prize of, I think it's $10,000, which is quite a big prize for like for this track, if you want to call it.
Yes, and it is possible that your team develops the best solution for one shot and for, overall. Like you
Yeah.
could do that. It's unlikely, but it's totally possible. So
If that happens, that would be exactly what Satya was talking about with this like 4 minute mile thing.
yes, to be pushing the industry forward by, yeah,
Yeah, for sure.
absolutely. So we've got a few more. I think we can do one more question here. This one was from Swaram, which is about the generated training data. Are we planning to provide any more information on that, or even like some folks were interested in, again, I think they're maybe thinking about trying how they can easily cheese this, asking about like, will we provide like a Blender file or information about the generated scene data for training?
So the data that we provide, the synthetic data that we provide has all the material properties, part positions in the scene, camera properties, light properties. All that information is the part of this synthetic data. Oh, sorry, no, I'm confusing here. Light is not part of that, but everything else is the part of that training data. We don't provide the scripts that we use to generate that data. However, I would really encourage people to take a look at BOP Toolkit. BOP Toolkit and other like BOP open source solutions have solutions for generating synthetic data. I think it's called Blender Prots. It's a special library. It's an open source library developed by BOP Fox that enables generating more synthetic data, and you're welcome to use it. So there are also other tools available out there that you can use to generate synthetic data. But this is like one you can easily start using and generate more data.
Fantastic. Thank you for that. I think that we've pretty much covered everything here. Folks, if you had a question that you asked and we just missed it somehow, please send us those questions to competition@opencv.org, and we will do our best to answer those, or ask them in the community Slack channel. The BPC channel is popping off over there. Also on the official OpenCV forum. Or just, LinkedIn, wherever. We're pretty active on all those things. Having said that, best of luck to you out there. Satya, I think you're ready to take us home, boss.
Yeah, thank you so much. Thank you, Vahe, for explaining this, and your second time on this webinar really, really helped our audience understand the scope of the problem, all the details of the problem. Thank you so much.
Thank you for having me.
And
And
thank
good
you,
luck
Phil,
to the
for. Go ahead, Vahe.
I was just saying good luck to the participants.
Good luck indeed. And thank you, Phil, for organizing this. And of course, thank you, our entire audience. Good luck. Please participate in this competition and win prizes.
Yeah, next week on OpenCV Live, speaking of prizes, we've got another challenge to tell you about. Stay tuned for next week's episode for a challenge separate from this one. But if you're, maybe this isn't quite your bag, we've got something else for you coming up soon. Take care of yourselves out there, folks. Take care of somebody else if you can, and have a great day wherever you may be. We'll see you next time.
All right. Thanks.